There are several possible causes for a ground fault circuit interrupter, or GFCI, to trip when a device is plugged into a deck receptacle that is fed from the GFCI. Firstly, there may be a ground fault in the deck receptacle or in the cable connecting it to the GFCI. Secondly, loose or damaged connections at the GFCI deck receptacle or in the cable can cause tripping. Thirdly, the deck receptacle may not be wired correctly, such as having the hot and neutral wires reversed. Fourthly, the GFCI in the kitchen could be faulty and tripping unnecessarily. Fifthly, the deck receptacle may be overloaded with multiple devices plugged in. To troubleshoot this issue, firstly check for ground faults. Use a ground fault circuit interrupter tester to detect any ground faults on the deck receptacle or cable. Secondly, inspect connections. Examine all connections at the GFCI, deck receptacle, and cable for any loose or damaged wires. Tighten any loose connections and replace any damaged wires. Thirdly, verify wiring. Ensure that the deck receptacle is wired correctly. The hot wire should connect to the brass terminal, a neutral wire to the silver terminal, and the ground wire to the green terminal. Fourthly, test the GFCI. Press the test button on the GFCI outlet. It should trip and then reset when the button is pressed again. If it doesn't trip, it may be faulty and need to be replaced. Fifthly, reduce load. Unplug any devices from the deck receptacle and try plugging in only one at a time. If the GFCI still trips with a single device plugged in, it indicates a problem with the receptacle or GFCI. If all other troubleshooting steps fail, replace the deck receptacle or the GFCI in the kitchen. More specifically, let's delve into the potential issues and solutions. A ground fault is a dangerous condition where current leaks from a hot wire to ground. This can happen due to damaged insulation, water intrusion, or faulty equipment. The GFCI is designed to detect these small current leaks and trip the circuit to prevent electrical shock. To check for a ground fault, use a GFCI tester. Plug the tester into the deck receptacle and press the test button. The GFCI should trip immediately. If it doesn't, there is likely a ground fault somewhere in the circuit. Disconnect the power at the breaker and carefully inspect the wiring and receptacle for any signs of damage or moisture. Loose or damaged connections can also cause the GFCI to trip. These loose connections create resistance, which can generate heat and cause the GFCI to misinterpret the situation as a ground fault. Carefully inspect all the wiring connections of the GFCI, the deck receptacle, and any junction boxes in between. Look for loose wires, corroded terminals, or damaged insulation. Tighten any loose connections and replace any damaged wires. Incorrect wiring is a common cause of GFCI tripping. The hot, neutral, and ground wires must be connected to the correct terminals on the receptacle. If the wires are reversed, the GFCI may not function properly and can trip unnecessarily. Double-check the wiring at the deck receptacle and the GFCI to ensure that the hot wire is connected to the brass terminal, the neutral wire to the silver terminal, and the ground wire to the green terminal. A faulty GFCI can also be the culprit. GFCIs are electronic devices and can fail over time. If you suspect that the GFCI is faulty, test it by pressing the test button. The GFCI should trip immediately, and the reset button should pop out. If the GFCI doesn't trip, or if it trips without pressing the test button, it's likely faulty and needs to be replaced. Overloading the circuit can also cause the GFCI to trip. Each circuit has a maximum current carrying capacity, and exceeding that capacity can cause the GFCI to trip. Unplug any unnecessary devices from the deck receptacle and try plugging in only one device at a time. If the GFCI still trips, the problem is likely not an overload. If the steps above do not solve the problem, it may be necessary to replace the deck receptacle or the GFCI. Start by replacing the deck receptacle, as it is the most likely culprit. If that doesn't fix the problem, replace the GFCI. When replacing electrical components, always disconnect the power at the breaker and follow the manufacturer's instructions. Always use appropriately rated devices. It is essential to ensure that the devices you use are rated for the intended application and environment. Using devices that are not rated for outdoor use, for example, can lead to premature failure and safety hazards. Additionally, ensure that the wiring and components you use are rated for the appropriate voltage and amperage. Ground fault circuit interrupters are designed to protect people from electrical shock by detecting ground faults, which occur when electricity flows outside its intended path. They are required in areas where water is present, such as bathrooms, kitchens, and outdoor locations. When a ground fault is detected, the GFCI trips the circuit, cutting off the flow of electricity and preventing a potentially dangerous shock. Regular testing of ground fault circuit interrupters is important to ensure that they are functioning properly. Most GFCIs have a test button that can be pressed to simulate a ground fault and verify that the device trips as expected. It is recommended to test GFCIs at least once a month. When wiring electrical receptacles, it is important to follow proper wiring techniques and adhere to electrical codes. The hot wire, which carries the electrical current, should be connected to the brass terminal in the receptacle. The neutral wire, which returns the current to the source, should be connected to the silver terminal. The ground wire, which provides a path for fault current to flow back to the source, should be connected to the green terminal. Proper wiring ensures that the electrical circuit functions safely and efficiently. Electrical connections should be properly tightened to prevent loose connections, which can cause overheating and electrical hazards. Use a screwdriver or other appropriate tool to tighten the screws and the terminals of electrical receptacles and other devices. Avoid over-tightening the screws, as this can damage the terminals. Proper grounding is essential for electrical safety. The grounding system provides a path for fault current to flow back to the source, tripping the circuit breaker or GFCI and preventing electrical shock. Ensure that all electrical receptacles and devices are properly grounded by connecting the ground wire to the green terminal. When working with electrical wiring, always disconnect the power at the circuit breaker before making any connections or performing any maintenance. This will prevent electrical shock and ensure your safety. Use a voltage tester to verify that the power is off before proceeding. Electrical work should be performed by a qualified electrician to ensure that it is done safely and in accordance with electrical codes. If you are not comfortable working with electricity, hire a licensed electrician to perform the work for you. Electrical codes and regulations are in place to ensure the safety of electrical systems and prevent electrical hazards. It is important to be familiar with the electrical codes and regulations in your area and to follow them when performing electrical work. Local building departments can provide information on electrical codes and regulations. Before undertaking any electrical work, it is advisable to obtain the necessary permits from the local building department. Permits ensure that the work is inspected and complies with electrical codes and regulations. Failure to obtain permits can result in fines and penalties. When working with electrical tools and equipment, it is important to use them safely and according to the manufacturer's instructions. Wear appropriate safety gear such as safety glasses and gloves, and avoid working in wet or damp conditions. Inspect electrical cords and plugs regularly for damage and replace them if necessary. Electrical systems should be inspected periodically by a qualified electrician to identify potential problems and ensure that the system is functioning safely and efficiently. Regular inspections can help prevent electrical fires and other electrical hazards. If you experience any electrical problems such as flickering lights, frequently tripping circuit breakers, or unusual odors, it is important to investigate the problem and take corrective action. These problems can indicate underlying electrical issues that need to be addressed. If you are not comfortable troubleshooting electrical problems, hire a qualified electrician to diagnose and repair the problem. Electrical safety is paramount. Taking the necessary precautions and following proper procedures can help prevent electrical accidents and ensure the safety of yourself and others. Remember to always disconnect the power before working on electrical systems, use appropriate safety gear, and follow electrical codes and regulations. When using extension cords, choose cords that are rated for the intended use and do not overload them. Overloaded extension cords can overheat and cause a fire. Avoid running extension cords under rugs or carpets, as this can trap heat and create a fire hazard. Replace damaged or frayed extension cords immediately. Surge protectors can help protect electronic equipment from voltage spikes, which can damage sensitive components. Use surge protectors on computers, televisions, and other valuable electronic devices. Avoid plugging multiple surge protectors into each other, as this can create a fire hazard. If you live in an area that is prone to power outages, consider installing a backup generator. A backup generator can provide power to essential appliances and equipment during a power outage. Hire a qualified electrician to install the generator and ensure that it is properly connected to the electrical system. Educate yourself and your family about electrical safety. Teach children about the dangers of electricity and how to avoid electrical accidents. Make sure everyone in the household knows how to shut off the power in case of an emergency. By following these electrical safety tips, you can help prevent electrical accidents and create a safer home environment. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations and safety. It is updated every 3 years to reflect the latest advances in electrical technology and safety practices. Electrical inspectors use the NEC as a reference when inspecting electrical installations to ensure that they comply with safety standards. Staying up to date on the NEC is important for anyone involved in electrical work. Changes in the NEC can affect the way electrical systems are designed, installed, and maintained. Familiarizing yourself with the latest edition of the NEC can help you ensure that your electrical work is safe and compliant. Several resources are available to help you learn about the NEC. The National Fire Protection Association, or NFPA, publishes the NEC and offers training courses and educational materials on electrical safety. Online resources, such as websites and forums, can also provide valuable information and insights into the NEC. Understanding the NEC is essential for anyone involved in electrical work. It provides the knowledge and guidance needed to design, install, and maintain safe and reliable electrical systems. By adhering to the NEC, you can help prevent electrical accidents and protect yourself and others from electrical hazards. When working with electrical panels, it is important to maintain a safe working distance. The working distance is the minimum clear space that should be maintained in front of an electrical panel to allow for safe operation and maintenance. The NEC specifies the required working distance based on the voltage of the electrical system. Always maintain the appropriate working distance when working with electrical panels. Arc flash is a dangerous phenomenon that can occur when electrical equipment is energized. An arc flash is a sudden release of electrical energy that can cause severe burns, injuries, and even death. Arc flash hazard should be assessed and mitigated to protect workers from potential injuries. Arc flash hazard assessments involve evaluating the potential for arc flash events and determining the appropriate level of personal protective equipment, or PPE, that is required to protect workers. PPE for arc flash protection can include flame-resistant clothing, gloves, and face shields. Lockout-tagout procedures are used to de-energize electrical equipment before performing maintenance or repairs. Lockout-tagout procedures involve disconnecting the power to the equipment and placing a lock and tag on the disconnect switch to prevent accidental energization. Following lockout-tagout procedures is essential for preventing electrical accidents and ensuring worker safety. Grounding and bonding are important safety measures that help to prevent electrical shock and fire hazards. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker, or GFCI, and preventing electrical shock. Bonding connects metal parts of electrical equipment together to create a low impedance path for fault current to flow back to the source. Proper grounding and bonding are essential for electrical safety. Electrical safety audits can help identify potential electrical hazards and ensure that electrical systems are in compliance with safety standards. Electrical safety audits are typically conducted by qualified electrical professionals. The audit involves inspecting electrical equipment, reviewing safety procedures, and identifying areas for improvement. Implementing the recommendations from an electrical safety audit can help reduce the risk of electrical accidents and improve electrical safety. Regularly review and update electrical safety procedures to ensure that they are effective and in compliance with the latest safety standards. Electrical safety procedures should be documented and communicated to all employees who work with electrical equipment. Providing regular training on electrical safety procedures can help ensure that employees are aware of the hazards and know how to protect themselves. Electrical safety is an ongoing effort that requires vigilance and commitment. By taking the necessary precautions and following proper procedures, you can help prevent electrical accidents and create a safer work environment. Electrical equipment should be properly labeled to identify its function and voltage. Labeling electrical equipment helps prevent confusion and ensures that workers are aware of the potential hazards. Use clear and concise labels that are easy to read. Regularly inspect electrical labels to ensure that they are intact and legible. The electrical panel should be kept clean and free of obstructions. Clutter and debris can create fire hazards and make it difficult to access electrical equipment in an emergency. Keep the area around electrical panels clear and organized. Regularly clean electrical panels to remove dust and dirt. Avoid using water to clean electrical panels, as this can create a shock hazard. Use a vacuum cleaner or dry cloth to clean electrical panels. Avoid storing flammable materials near electrical panels. Flammable materials can ignite if exposed to heat or sparks from electrical equipment. Store flammable materials in a safe location away from electrical panels. Electrical equipment should be properly maintained to ensure that it is functioning safely and efficiently. Regularly inspect electrical equipment for signs of damage or wear. Repair or replace damaged electrical equipment promptly. Follow the manufacturer's recommendations for maintaining electrical equipment. Avoid making unauthorized modifications to electrical equipment. Unauthorized modifications can void the warranty and create a safety hazard. Consult with a qualified electrician before making any modifications to electrical equipment. Electrical equipment should be protected from the element. Exposure to moisture, sunlight, and extreme temperatures can damage electrical equipment and create a safety hazard. Install electrical equipment in a protected location. Use weatherproof enclosures for electrical equipment that is installed outdoors. Protect electrical equipment from direct sunlight. Maintain a consistent temperature in areas where electrical equipment is installed. Electrical equipment should be properly ventilated. Overheating can damage electrical equipment and create a fire hazard. Ensure that electrical equipment is properly ventilated. Avoid blocking ventilation openings. Use fans or air conditioning to keep electrical equipment cool. Electrical equipment should be properly grounded. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or GFCI and preventing electrical shock. Ensure that electrical equipment is properly grounded. Use a ground fault circuit interrupter or GFCI to protect circuits that serve wet locations. GFCIs detect ground faults and trip the circuit, preventing electrical shock. Install GFCIs in bathrooms, kitchens, and outdoor locations. Test GFCIs regularly to ensure that they are functioning properly. Electrical safety is a shared responsibility. Everyone has a role to play in preventing electrical accidents and creating a safer environment. Be aware of electrical hazards. Follow safety procedures. Report any electrical problems. By working together, we can make a difference in electrical safety.